Hey guys, what's up? Welcome to our next Honors Algebra 2 Flipped Classroom lesson. Today we're talking about solving systems of linear inequalities, and our objective, what you need to know by the end of this class here, what you can use to kind of assess yourself, make sure you're mastering these lessons, are you're going to solve and graph systems of linear inequalities. So you should be able to do that by the end of today's lesson. Okay? So what we're going to do with systems of inequalities, we're still looking for points that make both of these inequalities true. Okay, that's going to look a little bit different. When we are looking for solutions of linear inequalities, of systems of linear inequalities, we're going to graph both of these inequalities. Okay, so we're going to get both of our inequalities in slope-intercept form. So for equation 1 up here, going to do add 3x on both sides, and then we have 2y is greater than or equal to 3x plus 2. Divide both sides by 2, get y by itself. So y is greater than or equal to 3 halves x plus 1. Okay, divide everything on the other side by 2. So, and then for inequality number 2 up here, that's already in slope-intercept form. Y is already outside. So let's go and graph this. Let's graph inequality 1 in green. So what is my y-intercept of this inequality? The y-intercept is going to be 1. What's the slope? The slope is going to be 3 over 2, so we're going to go up 3 over 2, and down 3 to the left 2. Now do we want to use a solid line or a dashed line? We're going to include this line as part of our answer, so we're going to use a solid line. Remember, if it's an or equal to inequality, we're going to use a solid line. Alright, so let's look at inequality number 2. We'll graph that in red. What's my y-intercept? The y-intercept is going to be positive 3. So I'm going to start at 3. What's the slope? The slope is 4 over 1. So I'm going to go up 4 over 1, or down 4 to the left 1. And now do I want to use a solid line or a dashed line? This is not or equal to. It's just less than, so we don't want to include the line as part of our answer, so we're going to use a dashed line. Alright, so now let's think about where we're going to shade stuff. Okay? So let's substitute in the point 0, 0, see if we want to shade the point 0, 0, see if that's part of our answer for these two inequalities. So for inequality number 1, if we substitute the point 0, 0 in, 0 is going to be greater than or equal to 1. 3 halves times 0 would be 0. Alright, now 0 is not greater than 1, so 0, 0 is not part of our answer, so we want to shade the other side of this inequality. Alright, let's take a look at inequality 2. If we substitute in 0, 0, we're going to get 0 is less than 3. Is that a true thing? Absolutely it is. So we do want to include 0, 0 in our answer as part of inequality 2. Alright, so now you're thinking, what kind of points make both of these inequalities true at the same time? Well, it's the points where both inequalities are shaded in the same spot. These points make both of them true. They're both shaded here. Okay, so it's the intersection of the solutions for these two separate inequalities. Okay, so it's that black shaded area. We're not including the red dotted line. We are including the green solid line. Okay, so now we're going to give two ordered pairs that are solutions. So anything in that black area would be a solution. So we could go over 1, up 3. That'd be an example of a solution. Or we could go over 2, up 5. That'd be in that black area as well. 2 points that are not solutions. Anything that's not in that black area, we could choose for that. So 1, 0 is not in that black area. Negative 2, negative 8, also not in that black area down here. Definitely not in the black area. Alright? And this black area continues forever, just like these lines. Okay? Now, a question I like to ask is the intersection of these two lines going to be part of my solution? The answer here is no, because it's not going to make both of my inequalities true. This greater than or equal to inequality, it would make that true, because this is greater than or equal to the line, the green line. But It's not less than this line, okay? It can't be equal to that line in order for it to be a solution. So it's not a solution to the red inequality up here, inequality number 2. So it would not be a solution of this system of inequalities. Now, if this was less than or equal to, it would be a solution because it would be equal on both of those inequalities. All right, let's check out one of our special cases. Just looking at this inequality, you should be able to identify that these are going to be parallel lines. They have the same slope. They have different y-intercepts. So let's go and graph these. First one's going to be in green. So what's my y-intercept for the top one? Y-intercept is going to be 5. What's the slope? The slope is going to be -2 over 1. So we're going to go down 2 to the right one, or up 2 to the left one. Now, am I going to use a solid line or a dashed line? It's not an or equal to inequality, so I'm going to use a dashed line. Okay, so let's graph the second one here, red. Y is less than or equal to -2x minus 4. What's my y-intercept? My y-intercept is going to be -4. What's my slope? My slope is -2, so up 2 to the left one, or down 2 to the right one. Am I going to use a solid line or a dashed line? It's an or equal to inequality, so I'm going to use a solid line. So now let's check out how the point 0, 0 looks in both of these. If I'm plugging the point 0, 0 to the top equation, I'm going to get 0 is greater than 5. Is that true? No. So, shade everything on the other side of my green line. Let's check it out with the second inequality. Alright? So let's do it in 0, 0. We're going to 0 is less than or equal to -4. Is that true? No, it's not. So we're going to shade on the other side of inequality 2 down. Okay, so now, what points make both of these inequalities true at the same time? There aren't any because these shaded regions don't overlap. Nowhere do the solutions of inequality 1 and inequality 2 share any ordered pairs. So, describe the solution. It's going to be none. No points. No points make both of those inequalities true. Alright, so the way this looks in an application typed setting. Let's go ahead and read through this. When you've read through this, identify some keywords, identify things we're looking for. Okay? Now, there are two things that Alice is bringing to a party. She's bringing some pepper jack cheese, she's bringing some cheddar cheese. So let's use X to stand for pepper jack and Y to stand for cheddar. Okay? She wants to have at least 2 pounds of each, which means that X has to be greater than or equal to 2. That's what at least means. At least means greater than or equal to. And Y also needs to be greater than or equal to 2. Alright. Now, she wants to spend at most $20 on cheese. Pepper jack cheese costs $4 per pound. So there's your per stuff. Now we're going to multiply. And that means our variable is going to be pounds of pepper jack cheese or pounds of cheddar cheese. And that's what we have up here. The pounds of cheddar cheese has to be at least 2. Pounds of pepper jack has to be at least 2. So, pepper jack cheese costs $4 per pound. And pepper jack is X here. And we're adding more pounds when we take into account cheddar cheese. So cheddar cheese is 2 per pound. And she wants to spend at most, so that's going to be less than or equal to at most. We can include 20. We want to spend at most $20. Alright? So, just like we did in the last couple of examples, we're gonna graph all of these. There's inequality 1, there's inequality 2, there's inequality 3. First, we need to get inequality 3 in slope intercept. So we're going to subtract 4x on both sides. And then 2y is less than or equal to negative 4x plus 20. Divided by 2 on both sides. And we get y is less than or equal to negative 2x plus 10. Alright, which probably means we should go up by 2 on our y-axis here. Alright, just so we can have a y-intercept of 10. So, let's graph inequality 1 in green. X is greater than or equal to 2. So we want to look at the line where x is always going to be 2. X is always going to be 2 on this vertical line. Okay? And we want to shade all of the x values that are bigger than 2. So we're going to shade to the right of this line. And it's a solid line because it's or equal to. Okay? Let's graph inequality 2 in red here. Y is greater than or equal to 2. So we're looking for the line where y is going to be equal to 2 all the time. Remember, we're going up by 2's on the y-axis, so that's the line we're looking at. And it's going to be greater than, so we want to know when the y's are going to be above 2. So that's all these points here. And let's go ahead and just graph inequality 3 in blue. Inequality 3 has a y-intercept of 10 and a slope of negative 2, so down 2 to the right 1, down 2 to the right 1, and it's less than or equal to, so we want to include that line as part of our solution. Okay, so it's going to look like that. And now, look at the points where it's going to intersect, where all 3 of them are going to be located. And that's going to be in this area right here. Okay, and again, the points where these 3 inequalities intersect would be examples of solution points because they're all or equal to inequalities. Alright, so we showed all possible combinations of 2 cheeses. List 2 possible combinations. So we could list any 2 points that are going to be in this area. So something like 3, 3. Looks like 3, 3 is going to be in this area. So 2 possibilities would be 3, 3 and 2, 4. 2, 4 would be on the line x equals 2. So that's okay. We want to include that line, so we're fine there. Think about what those mean. We said x stands for pounds of pepper jack. So in this point up here, we could get 3 pounds of pepper jack, 3 pounds of cheddar cheese. This point right here, we could get 2 pounds of pepper jack, 4 pounds of cheddar cheese. Alright? So, you guys have this. Write down any questions that you have for me tomorrow. Have a good night. I'll see you tomorrow, guys.